Hi guys, welcome back to another lesson in geometry. In today's lesson we're going to look at angles and angles within parallel lines. Let's jump in. So let's just begin by recapping parallel lines and what that means. So parallel lines are lines that run in the same direction but never touch. So like a train track, unless one of them diverts off that parallel path, they will always run in the same direction but never touch. Now, let's look at vertically opposite angles again like we did in the last lesson. We know that opposite angles are equal. Now, if we're talking about two parallel lines with one line intersecting them, what we're saying is we've got two sets of vertically opposite angles and they're identical. So these four really are identical, and these four are identical as well. Now, there's a bit of language we have to learn when we're talking about parallel lines and angles within parallel lines. So the first one is co-interior. Now, interior means internal, so we're going to be thinking about two lines that are internal like so. Now, if we look at these don't look identical. So there's some relationship between them, but it's not because they're identical. If we were to put them back to back, we would find that they add up to 180 because they'd form a straight line. Then we have alternate angles. So alternate angles are both inside the parallel lines but opposite to each other. Now these look the same, don't they? So we say that these are equal. Then we have corresponding angles. Now corresponding angles are identical, so in this case both of them are below the parallel lines and on the right side of our intersecting line. Now that line should go further, but I made a mistake with the animations on my slide, so it didn't quite come up. But as we can see here, they are equal to each other. So this spot down here is corresponding to this one, and they look the same, don't they? This one here is corresponding to this one because they're in the same position on that parallel line. Now these terms, co-interior, alternate, corresponding, it's so important that you memorize these. So you need to get someone to quiz you so you remember. Let's give some examples now. So name the angle that is alternate to C. So C is here. So we're talking about opposite side of the line, and they're going to be at the bottom. So we have this one here is alternate to this one here. So we say C is alternate to F, and we can see that it makes this Z shape. So they're both inside the Z shape. Now corresponding to C. Now corresponding is the same position but on the other line. So if E is here, corresponding, so it's above the parallel line and on the right of the parallel line. So we go above the parallel line and on the right means that it's A. So A is corresponding. Now we can find the size of the angles as well. So these two angles here are co-interior, and if we remember from our definition, co-interior adds up to 180. So we would go 180 take away 37, which gives us y equals 143. So this one here, these two are corresponding, and we can see that they look similar sizes, and we know that corresponding angles are equal in size, so we can simply say x equals 64. Now these aren't hard if you put in some effort and you learn the language. You're not just going to know it off by heart without trying. You need to put in some effort here. So find the value of A. Now this one looks a bit different because it doesn't look like the lines we've seen previously, but these little arrows show that they're still parallel to each other and it has a line running in between. So these would still be alternate angles, okay? So see how we can draw our lines out to make our same parallel lines. So 35 is alternate to A, so A equals 35. Thanks for watching, guys. Remember, if you have any questions, please make sure you ask. Otherwise, I'll see you in the next lesson. Thanks, guys.